to Module 3, Part 2. So in this live lecture, we're going to go ahead and talk about systems of equations. So last week we talked about linear equations, and we talked about the fact that there are two variables, there's two unknowns. Well, in this section, we're going to look at linear equations that have two variables, but we're going to look and see if we have two equations, is there a way to find a solution that works for both of them? And we're going to solve this system of equations using the substitution method and the elimination method. Both methods can be used on either type of system. However, there's ideal times when you're going to want to use substitution, and there's ideal times you're going to want to use elimination. And I'm going to talk about that. So make sure you concentrate on those two things. So as I mentioned before, a system of linear equations is a pair of linear equations, so two lines. And what you're doing is imagine graphing those two lines. The solution is going to be the ordered pair where they cross, or where do they intersect. That's the point that we're looking for. So we're looking for a solution of x and a solution of y when we're solving a system of linear equations. And as always, there's only going to be one, not as always, but there's only going to be one solution this time. Remember before, linear equations have an infinite number of solutions, anything that fits a line. Well, in our practice problems in the first part, there's only going to be one solution. Okay? And of course, that's an ordered pair where they intersect. So you're looking for x and y. So let's start off by looking at a couple of linear equations. I'm going to call this equation 1 and this one equation 2, just to help reference so we know what we're talking about. And what they ask is they ask to check that this point is a solution. So when they ask us to check things, what should we do? How do we check things? We've got to plug it in, plug it in. Exactly, Sonia. Yeah, plug it in, plug it in. So we're going to plug in 3 for x and 4 for y. Remember, it's always x then y into both equations. The solution has to work for both equations to be a solution of the entire system. So let's plug it in. So x plus y equals 7. X gets replaced with 3. Y gets replaced with 4. Yep, you've got two numbers which are equal. That means it works in equation 1, but it has to work in equation 2 as well. So x minus y equals -1. X is 3, y is 4. Simplify, 3 minus 4 is -1. Woohoo! It works in equation 2 as well. Since this point works in both of our equations, we would say, yes, the point 3, 4 is a solution of this system. Woohoo! Yay! Okay. Now, if it worked in one but did not work in the other, that means it is not the solution of the system. It has to work in both. So make sure you plug it into both equations. Okay. So when we're talking about solving systems of equations, there's actually 3 different methods that you could use. The first one is graphing, where you graph the two equations and you look where they intersect and you find their solution. That's one method. We're not going to use that method just because it becomes difficult if you're working with like fractions or decimals or things like that, because we can't quite see 2.5, you know what I mean? So instead, we're just going to concentrate on substitution and elimination method. Those are the two methods we're going to learn to use. So let's start this off by talking about the substitution method. So the substitution method is where we're going to take one equation and substitute it into the other equation. Okay, how do we do this? Well, the first step is to get one of the variables by itself. So you're either going to have y equals something or x equals something. Essentially, you want to get the variable that has a coefficient of 1 by itself. Okay, so you would move everything to the other side so that either y or x would be by itself. Once you have that variable by itself, you're going to take the expression that it's equal to and you're going to substitute it into the other equation for that variable. So if it's set equal to x, I'm going to substitute it in for x. If it's set equal to y, I'm going to substitute it in for y. Okay. Then we're going to go back to our solving techniques. Remember week 1 when I was like, solving equations is going to be the backbone of everything. We're doing it again. So we're going to solve for the variable. Once we have one variable, we need to take that, plug it back into one of the equations, solve, and then you'll have the second variable. And of course, step number 5 is my favorite. Check! Of course, we're not going to do that for every problem just because time, but I do encourage you guys to check it and make sure it works in both equations. So let's start with the first problem. So again, I'm going to label my equations, equation 1 and 2. Remember, this is optional, completely up to you. So equation 1 has y equals 3x plus 6. Equation 2 has negative 2x plus 4y equals 4. Well, step 1 in substitution is to get a variable by itself. So I'm going to look at these two equations. Is there a variable that is already by itself? If I look here, is there a variable that's already by itself on one side of the equation? Yeah, y. In the first equation, notice that y is just chilling by itself. It's not being multiplied by anything. It's just like, hey, I'm by myself. And so they've done the work for us. The y is by itself. It's set equal to 3x plus 6. So I'm going to circle the expression that y is equal to. And step 2 is I'm going to substitute it into the other equation. Now I need to substitute it in for the variable that it's set equal to. So I'm going to plug it in for y since it's equal to y. So go ahead, plug it in, rewrite this equation, negative 2x plus 4 times. Now I'm replacing y with this expression because they're equal, so I can do that. So notice I replaced y with this expression, but I put it in parentheses. Everybody see that? I put it in parentheses because I'm saying this 4 needs to multiply everything in that parentheses. So be careful. Don't forget those parentheses. So that was the new part. Now we're just going to go back to solving. So step 1 in solving, we got to get rid of those parentheses by distributing in a positive 4. So this would be negative 2x plus 12x plus 24. And then we got to go ahead and simplify the left-hand side. Add together your like terms. Negative 2x plus 12x is going to be 10x. Now, we can't add these two together. They're not like terms. So let's go ahead and subtract 24 to the other side. Got to move that constant to the right. So this is 10x equals, what is that, negative 20? Final step is to divide both sides by the coefficients. X equals negative 2. Any questions on the solving part? Hopefully that's a lot of review. Are we feeling confident about the solving? So once you find one variable, now we're going to go ahead and solve for another one because remember you want your x variable and your y variable. You need both of them. So if we have one value, what we can do is we can substitute it back in to one of the equations. Now, it does not matter which equation you substitute this value in for. You could substitute it into equation 1 or equation 2. I don't care. I'm going to substitute it into equation 1 because why not? If you substitute it into equation 2, you'll get the same thing. So equation 1 is y equals 3x plus 6. I'm replacing x with -2 because that's what it's equal to. So x is -2. 3 times -2 is -6. Add those together. Y is equal to 0. So my final answer is going to be -2, 0. So these two lines are going to intersect at -2, 0. That's where they're going to cross. So this is the point that works in both the first equation and the second equation. And we could go ahead and check by plugging it back into both equations. I'm not going to do that because of time, but that's generally the idea. So this is substitution. Let's go ahead and practice some more. I have several practice problems today to work through. So, excuse me. So here we have two equations again. Now, looking at these two equations, there's no variable that's by itself. If you look over here, y was just chilling by itself. There was no addition, no multiplication by numbers, just y. Over here, though, you have 2 times x plus 5 times y going on. You have x plus y going on. So you have more stuff going on. So we need to go ahead and rewrite one of these equations so that we do have a variable by itself. That's what we want. So I'm going to look at that second equation, and I'm going to notice that both the x and the y have a coefficient of 1, right? There's that invisible coefficient of 1 in front of those variables. So those would be pretty easy to isolate if I wanted to. So why don't I go ahead and take equation 2 and rewrite it. So what I'm going to do is I'm going to actually isolate x. I'm going to get x by itself because I want to show you that you could get x by itself or y. It doesn't matter. So the first step would be get rid of that y. It's currently being added, so we have to do the opposite, which is to subtract. So this becomes x equals -1 minus y. X equals -1 minus y. Notice the x is by itself now. Right? X is by itself. It's not being multiplied. There's no addition, anything like that. Now we can go ahead and circle our expression. And I'm going to substitute that into equation 1, which is the other equation. Now, should I substitute it in for x or should I substitute it in for y? What do we think? I should put this expression in for x. Very good, because it's equal to x. So let's take this equation 2 times, I'm replacing x with this expression, -1 minus y. And then I'm going to write down the rest. I really hope I'm not getting sick, guys. It's the worst. I know it's going around. So we rewrote the equation. We replaced x with -1 minus y. Notice I used parentheses. So what do we do next? Simplify and solve. So go ahead and try and solve this equation. So we always start off the same way. We've got to get rid of those parentheses by distributing. -2 minus 2y. Drop down the rest of the equation. Take our like terms, add them together. I'm going to be very cautious about that negative though, right? There's a -2 out front. So I'm ignoring the negative 2. I'm talking about the negative 2y. Negative 2y plus 5y added together becomes positive 3y. Okay. Now that we have each side simplified, let's go ahead and get rid of that constant. The opposite of subtracting is to add. So it looks like we have 3y equals 9. Divide both sides by 3. You have your first variable, y equals 3. Am I done? No, we have to solve for the other one. So I'm going to plug it back. Now, does it matter which equation I plug it back into? Do I have to plug it back into like equation 1 or equation 2? No, I could plug it into whatever, right? So I'm going to go ahead and plug it into equation 2. I'm going to always use those original equations though. So I'm going to plug it back into equation 2. If you plugged it back into equation 1, that's perfectly okay. You should get the same thing. So this is x plus y equals negative 1. That's the original equation. Y is 3, so replace y with 3. And I'm going to solve for x. So I need to get rid of this plus 3, so I'm going to subtract it. So this is x equals negative 4. Is that what we came up with? Questions on any of those steps? Anything you want me to talk through again? So your final answer will be negative 4 comma 3. This is where those two lines intersect. So with substitution, the key is to get one of the variables by itself by adding or subtracting the items to the other side, and then plugging that expression into the other equation. And from there, it's just what we've done before. Simplify, solve, some more practice kind of worked in there. Plug it back into one of the equations, and you should get the same thing. So the final answer would be negative 4, 3. And of course, you should check your answer by plugging it back in. On your quiz this week, I would strongly suggest checking your work. Run through the questions first, then check. Okay, so Module 3, Part 2, Live Classroom Code Word. Given it kind of early today, but it is Bernoulli. So make sure to write that down. He's another mathematician. I think he's from the 1700s. The wig kind of screams 1700s, doesn't it? He doesn't look like the Three Musketeers guy from Part 1. But Module 3, Part 2. So make sure you write down Bernoulli. And then we are going to continue on to the elimination method. So the substitution method, you're substituting in. With the elimination method, it's a little different because you're going to be eliminating one of the variables. And the reason why we use the elimination method is sometimes we have systems of equations that are extremely difficult to get a variable by itself. You might end up with fractions, with really nasty decimals. Nobody wants that, right? Nobody wants that. So instead, we have another method, the elimination method. It allows us to not have to work with those decimals and stuff like that. So if you have a system where we can't easily isolate either the x or the y in an equation, you're going to want to use the elimination method. This is the method that you probably want to use on your homework assignment. You don't have to, but I think it's easier to use this method on your homework assignment. Just a heads up. Okay. That doesn't mean you can't use the substitution method though. I'll talk about that at the end. So elimination method. The first step is to pick a variable that you want to eliminate. Now, this comes with practice and time to figure out what's the easiest variable to eliminate. But essentially, Your variables only eliminate when they have the same number. Okay, so if like it's 2x, the other variable has to be a negative 2x, okay? They have to have the same number, but one has to be positive and the other has to be negative. So there'll be times when you'll have like, okay, let's say you have 4y and 5y. And you're like, well, those don't match. 4 and 5, if I add them together, I get 9. I want to add them together to get 0, so they cancel. So what you're going to have to do is you're going to have to multiply one or both of the equations by the opposite coefficient to change the entire equation such that these variables will cancel. So my example here would be that we would multiply by the opposite coefficient, so 4 times 5 and 5 times 4. What ends up happening when you multiply by the opposite coefficient is you'll get 20y and 20y. You have the same number. The only thing you need to do now is make sure that one of them is a positive and the other is a negative. So if you have two positives, you need to throw a negative on one. So that will make your second variable a negative, such that when we add them together, we get 0. And we'll go through different scenarios and look at different examples of that. But that's basically what we're doing. Okay. And then after that, you're going to, once you multiply either one or both of the equations, you're going to add together the two equations. Add them together. And what'll happen is a bunch of stuff will cancel and then it'll be really easy to solve. Okay. Super easy to solve. Then you're going to take that answer and we're going to do the exact same thing we did with substitution. We're going to plug it back in and solve. So the back half of this method is identical to the back half of the substitution method. So sweet, we're only learning that first little bit. And of course, check your answer, right? You're like, you always say that. Okay, so here's my first example. Now, you could use substitution to solve this. That would be perfectly acceptable. However, we can go ahead and actually use the elimination method. And what I do is I check the coefficients first. This is a positive 1x and a positive 1x. If I added that together, I would get 2x. Well, that doesn't cancel. That's not going to eliminate that variable. What about the y's though? You have a negative 1 and a positive 1. What happens when I add those together? I get 0. That cancels. So we've actually already eliminated one of the variables because they were already opposite numbers. One was negative, one was positive, but they were the same number. So we're just going to add these two equations together. 1x plus 1x is 2x. Negative 6 plus 8 is 2. So this becomes 2x equals 2. Divide both sides by 2. X equals 1. See how once we eliminate a variable, it's actually really easy to solve it. It's like one step and you're done. Boom, that's it. And just like before, once you have one solution, we're just going to substitute it back in. This will be equation 1 and equation 2. Remember, it doesn't matter which equation you substitute it in for. I'm just going to go ahead and plop it into equation 1. X is 1. So I'm going to go ahead and subtract 1 from both sides. This is negative y equals negative 7. Now the y is not by itself. I still need to divide by that negative in front. So I need to divide both sides by negative 1. That becomes a positive y and a positive 7. So this would be our final answer. One comma 7. So with elimination, you're looking for that variable that has matching coefficients, just one is positive, one is negative. Okay. Let's go ahead and try another problem. So you may be looking at this one and saying, wait a second, there's no variables that match. 5 and 3, those aren't the same numbers. 4 and 2, those aren't the same numbers. What do we do? Well, we can go ahead and check to see if one of these is a multiple of another. So 3 and 5 are not multiples of each other. 3 times 1 is 3, 3 times 2 is 6. You can't multiply 3 by anything to get 5. You can't multiply 3 by a whole number to get 5. So how about 2 and 4? Can I multiply 2 by something to get 4? Two times what is going to give me 4? I can go ahead and multiply it by 2. Yep. So what I want to do is I want to eliminate these y variables. I'm going to do that by multiplying this second equation by 2. Now, when you multiply an equation by 2, you have to multiply every single thing. So 3x times 2 is 6x. Negative 2y times 2 is negative 4y. And 26 times 2 is what? 52. And then we're going to go ahead and just copy the first equation over. I'm going to show you why I didn't multiply it by anything. When one of the variables' coefficients are a multiple of another, you only need to multiply one of the equations by a number. So what ends up happening when we multiply the second equation by 2 and we just keep the first equation, what happens with these y variables? What happens when we add these together? Positive 4y minus 4y? It zeroes out, cancels. So we can just go ahead and add the rest. 5x plus 6x is 11x. And 14 plus 52 is 66. Then we're just going to solve it. Divide both sides by 11. X equals 6. And then back to what we did before. Plug this into one of the original equations. I don't care which one. And then solve. So let's substitute it into equation 2. Again, it doesn't matter which one you substitute it in for. So 3x minus 2y equals 26. Plug in 6 for x. 3 times 6 minus 2y equals 26. Let's see. It's going to be 18 minus 2y equals 26. We've got to go ahead and get that y by itself. Get rid of the constant. Subtract 18 to both sides. That zeroes out. 26 minus 18, what is that, 8? Yes, it is. Okay. Negative 2y equals 8. Divide both sides by negative 2. Y equals negative 4. Okay. Go ahead and write your answer. X always comes first. Y always comes second. Bing, bang, boom. We have our answer. So just to reiterate that when you're trying to solve a system, you're looking for which variables would be easiest to eliminate. If one is a multiple of another, you're going to multiply by whatever number it takes to get to that number. And you're going to multiply that entire equation by that value. Now, you always want to double check that your numbers match, but one is positive and one is negative, because remember, they need to add to 0. If they're the same sign, if they're both positive, they're both negative, they're not going to cancel. One has to be positive, one has to be negative. So you may be asking yourself, but wait, what if it's more complicated than that? Let's look at it. So in this next system, it gets a bit more exciting. 2 is 7 is not a multiple of 2. You can't multiply a 2 by a whole number to get 7. Same thing with 5 and 6. You can't multiply by something to get 6. So what I want to do is I want to go ahead and eliminate the x variable. We're going to change it up. So if one is not a multiple of another, we're just going to multiply by the opposite coefficients. Literally, I'm going to just multiply 7 by 2 and 2 by 7. This will always work for elimination method, multiplying by the opposite coefficient. So if you get stuck and you're like, I don't know if anything's a multiple of one another, just multiply by the opposite coefficient. It's a safe way to go. Now, be careful though, because remember, one has to be positive, one has to be negative. Right now, they're both positive. So how do we get one negative? Well, we're going to have to multiply by one negative. So let's go ahead and multiply the entire equations by these values. So 7x times 2 is 14x, 6y times 2 is 12y, and 10 times 2 is 20. This next one, I'm going to be extra careful because I'm multiplying by negative 7. So 2x times negative 7 is negative 14x. Positive 5y times negative 7 is negative 35y. And 23 times 7, what does that give me? Negative 161. Being very careful of that negative, right? Okay, once we multiply this, we need to go ahead and add it together. So what happens with the positive 14 and negative 14? It zeroes out, right? It's gone. So we're just going to add the rest together. So negative 12y minus 35y is going to be negative 47y. And 20 minus 161 is going to be negative 141. Final step, let's go ahead and divide by the coefficient. What you do to one side, you got to do to the other. Y equals, divided by negative 47, positive 3. Two negatives make a positive. Okay. So once I solve for one variable, what do I have to do next? I've got to plug it in, plug it in. Okay. I need to plug it into one of the equations. Doesn't matter which equation I plug it into. No, it doesn't matter. Whatever you're feeling. Whatever your heart desires. Plug it into equation, let's say equation 2. Why not? Doesn't matter. So y is 3, so I'm going to go ahead and replace y with 3. Simplify that side. 2x plus 15 equals 23. Now I need to solve for my x. Subtract 15 from both sides. 23 minus 15, 8. 2x equals 8. Divide both sides by 2. Bing, bang, boom. X equals 4. Yay! And we have our solution of 4, 3. Now, really, we should be checking our answers, but, you know, time. Time is a factor. So, just plug it back in, just like we did in the beginning. Plug it back into both equations. Make sure it works in both. You can literally just plug it in real quick to check in that second equation. 7 times 4 minus 6 times 3. Does that give me 10? What is that? 28 minus 18. Yes, it does give me 10. Woohoo! And we should also plug it into that second equation just to double check we didn't mess up our math, right? So 2 times 4 plus 5 times 3. Does that give me 23? 8 plus 15. It sure does. So it works in both. Yay, we're so happy. Okay, that's a smiley face. It's happy. Okay, so that was super exciting. The main takeaway of this problem that I want you guys to concentrate on is if you have two variables where one is not a multiple of another, right? 7 is not a multiple of 2. What we need to do is just multiply by the opposite coefficients, okay? Multiply by the opposite coefficients and make sure one is positive and one is negative. If we need to flip the sign on one, we're going to multiply by a negative on one. And this is the part where it's very meticulous. Make sure you use a calculator, do your multiplication real quick to make sure you've got it. Because if there's any kind of like miscalculation, it's really easy to do. It can throw off your answer and things get crazy. We don't want that. So just keep that in mind. Okay. We made it to the back half. So in the back half, we're going to talk about a couple of special cases. So these special cases are where the answer is not just one solution. Like so far we just had an ordered pair. One ordered pair, that was your solution. Bing, bang, boom. That's it. Nothing fancy. But there are cases where a system has either an infinite number of solutions or no solutions. So we're going to talk through both of those. The first example is when there are parallel lines. Now, we talked about parallel lines in part 1. Remember, they go the same direction, but the idea behind parallel lines is that they never cross, right? They never meet. They just go side by side forever and ever and ever. So there's no solution because the solution is where lines cross. If they don't cross, there can't be a solution. So what'll happen is when you're solving your system, you're going to eliminate all the variables. All the variables are going to vanish and you're going to be like, wait, where did my variable go? What's my answer? When you eliminate all your variables, it actually ends up being one of these two categories. So eliminate all variables. It falls into one of two categories. Now, if you end up with two numbers which are not equal, such as 0 does not equal 1, 5 does not equal 12, anything like that, your answer is going to be no solution. These lines are parallel lines. Okay, that's essentially what it means. It means they'll never meet. There's no value that you can plug in that will make those two lines equal. Never going to happen. The second special case you could have would be where the lines are the same line. Essentially, these lines are lying on top of each other. And more than likely, one is just a multiple of another. So where do these lines cross? Well, they cross everywhere. Yay! So any point on that line would be a solution. So we would say there was an infinite number of solutions. Infinite number of solutions. And this is going to occur again when you eliminate all variables. But this time, you're going to get two numbers which are equal. 0 equals 0, 1 equals 1, 2 equals 2. Most likely you're going to get 0 equals 0. And so our answer, our solution would be infinite solutions. Basically, any point on that line would work because that's where they cross everywhere. So those are two special cases. Let's go ahead and practice and see when would they come up. So let's say you're solving the following example. And we're going to use substitution to solve. Now, remember substitution, you have to get a variable by itself. Is there any variable that jumps out at you that you're like, maybe we could solve easiest for that variable? Any variable out here that you're like, maybe we should solve for that one to get it by itself? So if we tried to solve for the x, we'd have to divide by that 3. And that can get tricky because it can run into like fractions and stuff, and nobody wants to work with fractions, right? So instead, I'm going to look at this y here. It has a coefficient of -1. That's going to be a little bit easier to isolate. So let's go ahead and rewrite this. 3x minus y equals 4. Let's go ahead and try to get that y by itself instead. Essentially, you're looking for the coefficients that have you're looking for the variables that have a coefficient of 1 or -1. Those are the ones that you want to isolate for using substitution. So step 1, we're going to go ahead and subtract 3x to the other side. Boop, that zeroes out. So you have -y equals 4 minus 3x. I don't care what order these are in because I'm not going to use the slope-intercept form. Next step, we need to get rid of that -1. So I need to divide both sides by -1. So remember, you want to divide both by the -1. So 4 divided by -1 is -4. -3x divided by -1 is going to be a positive 3x. Basically, we're just flipping both the signs. That's all that happens. There's no fractions, no decimals. Things are looking up. So now that we have the y by itself, we're going to take that expression that it's set equal to, and I'm going to substitute it into the second equation for which variable? What should I substitute that in for in the second equation? Since it's equal to y, I'm going to go ahead and plug it in for y. So let's plug it in. Remember, I'm using those parentheses when I plug it in. And I'm going to solve. So again, I'm going to do this fairly quickly. If you have questions, let me know. We distribute, minus 12 plus 9x equals -12. And then I'm going to add my like terms together. What is -9x plus 9x? 0. Oh no! These cancel. Bye-bye variables. And what I'm left with is a -12 equals a -12. Hold the phone. My variables are gone. What do I do? Well, I go back to this fancy slide or your page on your notes with all the information, and you go, this is a special situation that Alicia told me about. When my variables vanish, it's one of two situations. It's either no solution or infinite number of solutions. What do you guys think? Okay, we have -12 equals -12 is our final answer there. So what should that our conclusion be? Should it be they're parallel lines, there's no solution? Or should it be infinite solutions? Since these two numbers are equal, that means these are the same line. They're on top of each other. And so our final answer would be that there are infinite solutions. Sorry, I make sound effects sometimes. Okay, so infinite solutions. Boop, done. Yay! So you don't actually have to solve for anything here. Once your variables are gone, you just jump back to the slide and say, okay, it's one of two situations. Since we had two numbers which are equal, that means these are the same line, infinite solutions. Let's try another one. In this one, I'm going to go ahead and use the elimination method. Now, for the elimination method, I'm just going to go ahead and look at my first variables, 2x and negative 2x. Are they the same number? Yes, both of these are 2. Do they have opposite signs? Is one positive, one negative? Yes. Sweet. I do not have to multiply by anything. I can simply just add those two equations together. So let's go ahead and add those together. Positive 2x minus 2x is 0. What's positive y minus y? 0. Add the right-hand side. 12 plus 2 is 14. So this would be 0 equals 14. Hold the phone. The variables are gone. Oh, do you guys have negative 2 here? I thought I had corrected that on my slide. Maybe I did not. I apologize. If it's negative 2, it should be 10. I apologize. Okay. So it should be 0 equals 10, which is not possible, right? So what should our conclusion be? So once variables are gone, you go, wait, this is a special situation, and you hop back over here. So do you think our answer should be no solution or infinite solutions? It should be no solution. And the reason for that is because you have two numbers which are not equal. So our answer is no solution. Essentially, these are parallel lines. So no solution, yay. Okay. Boop, all done. Questions on the last two here? I just want you to be careful because when the variables vanish, that does not mean that our answer is like negative 12. That's not the answer. 10 is not the answer here. We have to go back and say, do I have two numbers which are equal, like here? Then it's infinite solutions. Two numbers which don't equal each other, no solution. There's no number that you can put in there that will be a solution of this system. No answer is going to work. Okay. So that was all I had today for the material. Let's go ahead and look at the homework though. So again, that was just a few examples. Make sure to pull up your notes. I do have several practice problems, so make sure you use substitution, practice that one. Elimination method, practice that one. There's more than one way to solve these. And then there's a couple word problems here that are kind of similar to the assignment, but not really, really close. So you can give them a try if you'd like to. But what I'm going to do is I'm going to go ahead and talk about our assignments for today. So make sure you've got the Module 3 Part 2 Live Classroom code word. Go ahead and put it in there from earlier. Module 3 written assignment. Now, before you try the assignment, I encourage you guys to watch the Module 3 written assignment help. It's in the course announcements here. And it goes through two word problems. The first one I show, I don't want to hear myself talk, but the first one, I think I use substitution. Yeah, I use substitution to solve it because you can easily isolate a variable. In the second problem, though, I show how to use the elimination method and multiply one of the variables by a number. In your word problem, you'll have to multiply 2, We did go through an example. This one here would probably be closest to, you have to multiply both of them by a value. Okay, so you might want to reference this problem here. Okay, so this is good though because it shows you the setup and different ways to solve the problem depending. So give that a look. And then I'm going to pull up the written assignment. And then, of course, I'm going to grab that rubric. Because literally, guys, I have the rubric up when I'm grading. And I literally just go through those checkpoints. And I'm like, did you do that? Yep, no. And you either get the points or you don't. Like straight up, no business about it. I will tell you what's happening right now. I will tell you that I'm working on grading things. I'm trying my best to get them done. I'm going to work on grading today, and I'm also going to work on grading tomorrow. So some of you may not get your feedback till tomorrow. I apologize. Sometimes the weeks are just like that where it's so busy. But Module 3 Systems of Equations. Your problem is that Betsy is fundraising for her soccer team by selling popcorn and cookies. Yum. She manages to sell 13 tins of popcorn and 19 tubs of cookies for a total of $321.20 on her first day of sales. The second day, she doesn't sell as much. She ends up selling 9 tins of popcorn and 15 tubs of cookies for a total of $234. What was the individual cost of each tin of popcorn and tub of cookies? So number one, you're going to list your variables. You're also going to define what those variables represent. Okay, what does X stand for? What does Y stand for? Or you could use A and B. I don't care what variables you use, okay? You can use P and C. P for popcorn, C for cookies. I don't care. Whatever you want to do. Then you're going to create 2 equations from the word problem. I kind of show you in your examples how to set those up. So if you haven't watched the word problem, that becomes a little clearer there. Now, be careful because you also need to include an explanation of how you created each equation. So a couple words, how you created those equations. I'm sorry, a couple sentences on how you created those equations. Don't forget that part right there. Now, of course, make sure you use equation editor because remember the equation editor is worth 2 points and you have to use it for all of your equations. Remember that's in insert equation right here. Sometimes it's hiding under the symbols button, but it's right there if you need it. Number 2, you're going to be solving the equations you just did using either elimination or substitution. Up to you which one you want to use. Honestly, elimination is going to be a little bit friendlier because the substitution method, when you plug it in, you're going to get some fractions and decimals, and you really don't want to round until the very end. So it gets kind of nasty. You can use substitution and use fractions. That's completely up to you. I'm just suggesting something. Take it or leave it. But for number 2, you need to show all your steps. There's going to be quite a few steps here, right? You need to explain your steps. What method are you using? What is your first step? Why are you multiplying by that value? What's your second step? How are you simplifying these things? Are you adding, multiplying, dividing? What are you doing? Once you have one value, what are you doing with that value? So by the end of number 2, see how it's like a whole page to do this? By the end of number 2, you should have your X value and your Y value, or your P and your C value, whatever variables you decide to use. So you should have both variables there. And I want you guys to be careful because you need to restate your answer in a complete sentence. So for instance, each tin of popcorn costs, enter answer and units there. Each tub of cookies costs, enter. That's a complete sentence. So just make sure that's a complete sentence. I want you to tie it back to the problem so we're relating it and it's not just a number. It's an actual value. We're connecting to these concepts. Number 3, this is the easiest part, guys. You're checking your solution. And you should be doing this anyways, right? Because we want to make sure it's correct. So you're going to take both of your answers and you're going to plug it back into both equations. And you're going to check that you get true statements in either case. So there's no solving here. It's just plugging it in, simplifying, checking that you got 2 correct solutions. Just like we did here in this part, the red part over here, where we just plugged it in, simplified. Yep, it worked in both. Cool. That's it. You don't have to explain anything. I mean, you could put a smiley face at the end. I don't care that it worked out, that you're happy. Cool beans. Okay. And of course, all equations have to be typed up in equation editor. I already mentioned that. No handwritten submissions will be accepted. If you're struggling on the Module 3 written assignment, of course, number 1, live classroom, rewatch this example. Number 2, rewatch the written assignment help video. That can be helpful as well. 3, you can always email me questions. Option 4, I have a lot of options here. You can always meet with a Rasmussen tutor right there. Lots of options here, guys. Tutoring information is actually right here if you have questions on it or you need more detail. It can walk you through the different options and everything in case you're not sure. I guess that's it for the written assignment. Were there any questions on the written assignment that you wanted to clarify? Oh, I should say that you can email me your written assignment before Sunday at noon, just like last week. You can email me your solutions and I'm happy to check them before you submit them. There are not any like redos on the written assignment, so email me before you submit if you want to check it, in other words. Okay. And then last but not least is the Module 3 quiz. So again, the Module 3 quiz, there is a practice quiz on the course homepage. Please give that a try before you take the quiz because the questions are going to be very similar. I don't even know what's on here right now, but oh, look, yay. All these people took it. Okay. So you can kind of see some of the questions and how the answers are going to be worded. So you can kind of see, you know, here's the first problem. Just add that together. And then work through it that way. And you can take that as many times as you want to. I would suggest taking notes on it, and then you can use those notes for the quiz as well. Any questions on the quiz, on the assignments for Module 3? You do have to use the Respondents Lockdown browser, just like before. You guys are mostly good with that, though, now. Okay. Well, cool beans. That is all I have for you guys today. Thank you so much for coming, each and every one of you. I really appreciate it. I love having you here. And if there's any questions that come up over the weekend, feel free to email me. And I hope everybody has a great weekend. Bye. Thank you, Ashley. Thank you, Joseph.